what's going on guys? In this video we are going to see how to solve a Cauchy-Euler differential equation. First of all, we have to know how to figure out whether a differential equation is Cauchy-Euler or not. To figure out a Cauchy-Euler, you have to look at the x power and also the order of y. Here we have x power 2 and the order of y is 2, right? Second order. So the power and order are matching. If it's 2, it has to be second order. If it's 1, it has to be first order. Here the x power is 1, it's first order. And here x power 0, because we don't have any x, it means x power 0. Then we don't have any prime, it means this is a 0th order. X power 0, 0th order. So all the powers and the y, the order of y next to it is same. Therefore this is a Cauchy-Euler differential equation. Okay, whenever we have a Cauchy-Euler differential equation, the auxiliary equation is going to be in this pattern: am square plus b minus a m plus c. Okay, this is the auxiliary equation. Now if it's normal differential equation like without Cauchy-Euler, what we do is, if it's double prime we equate that one to m square, and if it's just single prime we put m, and then if there's no prime we just put the coefficient in front of this one. Here the difference is we put this pattern: am square plus b minus a times m plus c. This is the auxiliary equation for Cauchy-Euler differential equation. Now what is this a value, b value and c value? A value is the one in front of this second order. Like in front of this x and y, do we have any number? We don't have anything here. It means that's just 1. Okay, a is equal to 1. And then for b, what is the number in front of this xy prime? We have 7. B is equal to 7. And what is the number in front of this x power 0 and this is 0 order, so we just put the coefficient, that's c is equal to 8. Okay, now we just have to plug all these values in this auxiliary equation, and that's gonna give us m square plus b minus a. B is 7 minus a is 1. 7 minus 1, 6. 6m, this would be equal to 0, plus 8 is equal to 0. Now the next thing is we have to factor this one. 4 times 2 will work, so we can write m plus 4 and then m plus 4, m plus 2. M plus 2 is equal to 0. So from this one we can see we are getting m is equal to minus 4 and m is equal to minus 2. Okay, we have distinct real roots. Like if it's not a Cauchy-Euler, if we have a distinct real roots, the general solution will be in this pattern. We will have y is equal to c1 e power x, e power m times x, negative 4x plus c2 times e power negative 2x. Okay, if it's distinct real roots in normal case, but this is not for Cauchy-Euler. For Cauchy-Euler the pattern is different. It's going to be, instead of e power x, we put y is equal to c1 x, right? Instead of e we put x, and we put this one as power, x power minus 4 plus c2 x power minus 2. Okay, that's going to be the solution, general solution of this Cauchy-Euler differential equation. Now let's look at another example. Now let's look at this one. Here we have x square, y double prime, power and order are matching, x, y prime, x power 1, first order, power and order are matching, 0th order, and x power is 0 because we don't have any x. So this is also a Cauchy-Euler. Now we know that for Cauchy-Euler the auxiliary equation is in this pattern. Let's write with a different color: am square plus b minus a times m plus c is equal to 0. Now we know that a is the value in front of the first term, that's a is equal to 9 in this case, b is equal to 3 in this case, 3 in this case, c is equal to 1 in this case because we don't have anything, c is equal to 1. Now let's go ahead and plug all the values. B is equal to 3, and let's go ahead and plug all these values. A is equal to 9, so this is going to be 9m square, and b minus a is 3 minus 9. 3 minus 9 is going to give us negative 6. So let's put negative 6 right here. Negative 6m plus 1 is equal to 0. Now let's see whether we can factor this one. This is going to be 3m minus 1 3m minus 1, 3m minus 1 is equal to 0. Okay, here we are getting m is equal to 1 over 3 and m is equal to 1 over 3. And if we have a situation like this, and if it's not a Cauchy-Euler, the general solution will be like this: y is equal to c1 e power 1 over 3x and c2 e power x multiplied by e power 1 over 3x if it's repeated real roots, because this is repeated real root, because we are getting same things twice. So repeated, when we have repeated, and if it's not a Cauchy-Euler, this is going to be the general solution: c1 e power 1 over 3x plus c2 x times 1 over 3x. But if it's a Cauchy-Euler, we know that for Cauchy-Euler we don't have exponential, we have x. So let's write the Cauchy-Euler solution. So this is not going to be correct for this one, because we are dealing with Cauchy-Euler. This is, if it's not Cauchy-Euler, it's going to be this pattern. If it's Cauchy-Euler, the solution is going to be like this. Let's write with a different color. We will have y is equal to c1 x power 1 over 3. Okay, you can see the pattern almost same, but x is in the below, right? Here we have e power, here we have x power, plus c2, and instead of multiplying by x, because to make this one linearly independent, we multiply this one by x. So for this one, we don't multiply by x, we multiply by ln of x. Okay, that's the difference. Ln of x and then multiplied by x power 1 over 3. That's the only difference. Okay, and this is the general solution for this differential equation. Now let's look at another case. Here we have another one, and you can see this is also a Cauchy-Euler, because x power 2 y double prime, the power of x and order are matching, and here x power 1 the first order, and here we don't have any x, it means x power 0, and we don't have any prime, it means this is 0th order. Okay, so this is a Cauchy-Euler differential equation. Now the next thing is, we know that auxiliary equation for the Cauchy-Euler is this pattern: am square plus b minus a times m plus c is equal to 0. Now a, b, c values. A is the value in front of this, the first value, that's x square y double prime. We don't have anything, it means a is equal to 1, and b is negative 9, and c is 28 in this case. Okay, let's go ahead and plug all these values. A is 1, so this is going to be just m square plus b minus a. Negative 9 minus 1, that's going to be negative 10. So here we will have negative 10 right here, 10m, and then plus c is just 28, that's equal to 0. Now can we factor this one? Okay, you have to use that formula, quadratic formula. If you use quadratic formula, you will get this answer: m is equal to 5 plus minus square root of 3i. Okay, so you can see this is a complex number. We have real number and imaginary number. So whenever we have complex number, and if it's not a Cauchy-Euler, we will have the solution like this: y is equal to c1 e power alpha x plus multiply by cos beta x plus sine beta x. Okay, this is the solution if it's not a Cauchy-Euler. But here we have Cauchy-Euler. For Cauchy-Euler, the solution will be, we will have x power alpha. So let's write the Cauchy-Euler solution. The Cauchy-Euler, y is equal to x power alpha. Alpha is the first term, this is alpha, this is beta. Okay, so x power alpha, that's x power 5, multiplied by c1 cos, and then beta ln of x. Here we have beta x, if it's not a Cauchy-Euler, beta x, and here we will have beta ln of x. Okay, and this one should be c1 and c2. If it's not a Cauchy-Euler, it will be like this: c1 c2 like this, and this is cos root 3 beta ln of x. Okay, ln of x, and then plus c2 cos, sine again beta ln of x. Beta is root 3 ln of x. Okay, so this is the solution if it's not if it's a complex number, and if it's a Cauchy-Euler, this is going to be the pattern. Okay, this is not the solution, because this is if it's not a Cauchy-Euler. If it's a Cauchy-Euler, this is the solution. Okay, that's it. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn differential equation, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.